Okay, Bismillahirrahmanirrahim. So we continue a little bit okay, on chapter 4, transformers. Okay, for voltage regulation. Okay, firstly look at the definition for voltage regulation. Okay, full load voltage regulation, VR is a quantity that compares the output voltage of the transformer at no load with the output voltage at full load. Okay, actually we compare the output voltage during no load and then the output voltage during full load. So we actually we need to observe what happen if we connect the load to the source. Usually there will be some changes in voltage, but for good voltage regulation, the changes is not high. So for ideal condition, the voltage regulation is 0%. So meaning that voltage during no load condition is equals voltage during full load condition. During no load and during loaded. So that is when the voltage regulation is equals to 0%. But in reality, that will not going to be happen because of there must be some changes. Because of when we connect the load to the source, the voltage must be dropped. So in general, voltage regulation, the formula is Vs no load. Vs stand for secondary voltage, minus Vs full load divided by Vs full load, multiplied by 100%. So the good voltage regulation is nearest to 0%. It differ from efficiency. As the efficiency higher, which is nearest to 100%, so the system is considered good lah. Right, so so remember, voltage regulation VR also can be performed either at primary or secondary side of the transformer. Because of we can refer our parameter either on primary or secondary side. If we are performed at primary side, Vs no load is equals to Vp, which is V primary. If we are performed at secondary, Vs no load is equals to Vp over A, which is we bring the voltage at primary side to secondary side. And then the parallel branch is neglected as the current flow is too small. So remember the final circuit for transformer test. This is the branch. So this branch is neglected because of the current flow through this branch is too small. Right. So so the final circuit is looks like this lah. Right. So actually originally this is a branch over here, but we neglected because of the current is too small. So this one is voltage regulation when we do analysis by referring at primary. So we know that this is the original equation or formula. Then because of we referred to primary, Vs no load is equals to Vp. So Vp minus AVS. Vs full load equals to AVS. We multiply, we bring the secondary voltage to primary side, and then divide by AVS multiplied by 100%. So actually the calculation that involved is how we want to determine Vp. So Vp is Is over A, which is secondary current that we bring on primary side. Is over A. So remember this is referred to primary. Multiplied by R equivalent, this one. Plus with Is over A, the same current that flow on Jx equivalent, and then plus with AVS. Okay, actually this formula is KVL. So voltage VP plus voltage drop across R equivalent P plus voltage drop across JX equivalent P, okay, and then plus with AVS. Okay, and then we can get VP. Okay, so okay, our purpose is to determine VP. Okay, so VS is the rated secondary voltage, AVS is rated secondary voltage referred to primary, and then theta based on power factor. So theta is based on question. Right. So this is okay, when the voltage regulation referred to secondary. Okay, remember when referred to secondary, VS no load equals to VP over A, which is we bring the primary voltage to secondary side, and then VS is still lagi VS full load, and then this is VS full load. So the difference is VP over A. Okay, and then what we want to determine is VP over A. Okay, sama juga. Okay, the current flow, okay, by using KVL, okay, negative VPA plus voltage across here plus voltage across here plus voltage here. So when we rearrange this equation, okay, dia akan jadi VP over A equals to IS, okay, secondary current angle of theta multiply by R equivalent plus IS secondary of angle of theta plus GSQ plus VS angle of 0 degree. Okay, so for secondary voltage, we assume that the angle is 0 degree. This equation actually you can write as this way: VP over A equals to IS angle of theta, okay, multiply with R equivalent plus JX equivalent. Okay, plus with VS angle of 0 degree. Because of this is secondary, referred to secondary, this is R equivalent S. This is also JX equivalent S. Okay, and then for this one, okay, for primary side, okay, actually you guys can write as, okay, VP equals to IS over A angle of theta multiply with R equivalent P, okay, because of we refer at primary, plus, okay, JX equivalent P, and then plus AVS angle of 0 degree. Okay, so remember all the secondary parameter we referred to primary because of this circuit is referred to primary. So primary IS originally at secondary, but we referred to primary by divide A, and then this one is also secondary voltage, so we refer at primary by multiply by A. And then for this one, VP originally at primary, but we refer to secondary by divide by A, and then this is originally at IS, so okay, it remains similar. So this one is secondary referred to secondary, and then this is originally at secondary side, so it will remain, okay, similar lah. Okay, so you have to remember these two equation for voltage regulation. Okay, primary, and then this is secondary. Okay, so next one we move to efficiency of the transformer. Okay, the general equation is, this is the symbol for efficiency. Okay, P out over P in multiplied by 100%. Okay, and then P in we can write as a P out plus P losses. Okay, and then P out lah. Okay, so refer to power flow diagram. This is P in, this is P out. Okay, so to determine P in, P out plus P loss. Okay, because of actually we know we can calculate P losses. So that's why lah we write how we want to determine P in by P out plus P losses. Okay, so P out also we can know the formula, which is P out VS IS cos theta, and then P loss is divided into two, PCU, P coupling and P core. Okay, PCU is P cuprum, and then cuprum ataupun copper lah, okay, in English, and then plus with P core. Okay, so refer to primary side. Okay, P copper, for copper loss, PCU IP squared, okay, I primary squared multiply by R equivalent P, and then for core loss, VP over RCP. Okay, so this one is actually this one this circuit. Okay, so yang ni adalah PCU, this is P core. So kenapa this one this is VP over RC? Because of voltage. Voltage is parallel with RC, so we can use formula P equals to V squared over R. And then for this one, okay, this is the current flow, IS. Okay, for this okay, so copper ni PCU, okay, we get during the we assume that the current flow is IP, so IP squared multiplied by R equivalent P. Okay, and then this one is because of parallel. Okay, the voltage parallel with R, so we can use V squared over R. This one is I squared over I squared multiplied by R. Okay, same goes untuk secondary, so IS squared, okay, instead of P, IP, so this one we use IS multiply by R equivalent QS, and then for core is VS squared divided by RCS. Okay, so for maximum efficiency, this is the formula VS IS cos theta. So actually this is PR. Okay, PR over PR plus P losses, which is P in. Okay, PR over P in is efficiency, and then multiply by 100%. Okay, so condition for maximum efficiency is, okay, when the P core is equals to PCU. Okay, for example, P core is 100 watt, so PCU is also 100 watt. Okay, and then cos theta is equals to 1. So yang this one you will replace with 1, this one you replace with 1, and then PCU P core will be equals to PCU. Okay, P core is equals to PCU. Okay, not PCU is equal to P core. So for example, when PCU is 100 watt, so P core must be 100 watt. Okay, not this is 100 watt, this is must be 100 watt. Okay, P core must follow PCU, okay, in order to get maximum efficiency. Okay, so lastly, okay, on the phasor diagram, so how we draw the phasor diagram. So actually phasor diagram is draw based on power factor, either lagging, leading, or unity power factor. So a few parameter that we have to consider. Okay, firstly is VP, and then we have VS, R equivalent, okay, and also IS. Okay, so this one let I show you how to draw this one. Okay, so firstly let's consider for lagging power factor. Okay, we know that the VS secondary voltage is 0 degree. Okay, so VS is at 0 degree, so you draw the VS. Okay, this is 0 degree, so this is VS. Okay, and then because of lagging, we know that lagging current lag voltage by theta, so you draw current. So this is IS, theta is this one lah. Okay, and then for R equivalent, this one. Okay, for R equivalent, this one. Okay, it will parallel with IS, so this one sama dengan this one, so this is R equivalent. Okay, R equivalent. And then for VP over A, okay, VP over A actually when you calculate VP, okay, dia akan ada angle between VS dan VP. So this is VP, and then this is angle between VP over A and VS. And then for this one JX equivalent you just sambung je. So this is JX equivalent S. Okay, remember firstly you draw the VS, okay, with angle of 0 degree, and then you draw the current with the angle of, this is angle, okay, based on power factor. Okay, and then because of current is lagging VS, so this angle is actually negative, and then the current is lagging VS, and then you draw the R equivalent that parallel with IS. Okay, so meaning that this one is, the angle is similar. Okay, the angle, this one is similar with this one, so this is R equivalent S, and then you draw the VP over A. Okay, the voltage that you find from voltage regulation, okay, either this one VP over A or this one VP. Okay, right. So and then lastly, okay, you just sambung between R equivalent and JX equivalent. So this is for lagging power factor. So next one is for leading power factor. So we know that when leading, I lead V S. Okay, so the angle must be positive, positive in angle lah. Okay, so firstly you draw the VS. Okay, VS must be angle of 0 degree. So this is 0 degree, and then you draw the IS. Okay, IS is positive, which is lead VS. So this is IS. So this is IS, and then you draw the R equivalent that parallel with IS. So this one, this is R equivalent. So the same angle theta here, and then this is the same angle. Okay, and then next one you draw the VP over A. So VP over A, okay, the angle slightly higher than VS. So this is VP over A. So this is angle theta. And then lastly you just sambung, okay, between R equivalent dan JX equivalent to determine JX equivalent. You just sambung R equivalent between VP over A. Okay, so yang ni lebih kurang dia punya gambar dia macam tu. Okay, this is how we draw for leading power factor. And then lastly for, okay, unity power factor. Okay, we know that unity power factor theta is 0. Okay, so theta is 0 for unity power factor. Okay, theta is equals to 0. Okay, IS is in phase, okay, with VS. Okay, so that's why theta dia adalah 0. So you draw the VS. So this is VS, and then this is IS. Okay, the same angle with VS. Okay, because of the theta is 0. Okay, and then you draw R equivalent S, okay, in phase with VS, because of actually R equivalent S is in phase, is parallel with IS. Okay, and then you draw the VP over A. So this is R equivalent S. So VP over A, okay, the angle must be higher compared to VS. And then lastly you sambungkan JX equivalent. Okay, so this is for unity power factor. Okay, that's all. Thank you.